Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, class. Hello, everyone. How are you today?
Good.
How are you today?
Good.
Okay. So, before we start our lesson today, let's take a moment to pray according to our individual beliefs. Let us pray. Begin. Pray. Finish. Okay. Is everyone already here?
Novel
As always,
is
novel. Vira juga ya?
Yes.
Oh, okay. Yeah, so before we dive into our lesson today, I want to talk about the rules in my class. I think everyone is already understand that we must respect each other. I will respect you as my student, and you have to respect me as your teacher. Everyone agree?
Yes.
Okay, so now let's do a quick review from the material last week. Okay, so what you remember from our last week lesson? Can anyone tell me? Yeah, Brian?
Already learned about enzyme.
Enzymes and Anissa, what?
We learned about the function and the shape of the enzymes.
Okay, correct. So last week we already talked about the enzyme and the function and also the specificity and the models. Now let's talk about something that might happen in real life. Have you ever had a fever?
Yes.
Okay, so when someone gets a high fever, your body doesn't feel normal, right?
Yes.
You're not feeling well. Maybe you lose your appetite too or feeling tired, okay?
Yes.
What do you think, like maybe there is something inside the body that might not be working properly when we're sick?
Yes.
Yes, okay. So what do you think could be the reason for that?
Because our body can function really well when we're sick.
Okay, interesting. Okay, so let's connect this to what we just talked about earlier, to those molecules that help our body's reaction. So, you said that the temperature maybe could affect how the bodies work. Yeah, okay, so if the temperature change, it could also change the way this molecule works, right?
Yes.
Okay, do you ever think like maybe there is something else in the environment that could also affect how the bodies work?
Yeah.
Yeah, can you tell me what is it? Maybe something like beside the temperature. Can you tell me? Okay, yeah, good job. So it's just not the temperature that could also affect how this molecule works. There's also pH, another one, okay? So based on all of that, do you already have a mind about the topic that we're going to learn for today? Can you tell me what is it? Today we're going to learn about right?
Vector and for enzyme action.
Okay, I can hear your voice, sorry.
Factor affect enzyme action.
Okay, yeah, correct. So today we're going to learn about the factor that could affect the enzyme action, okay? Okay, this is our learning outcome. So I hope after this test you can understand and explain the effect of the following factors on the rate of enzymes. Yeah, we will gonna discuss about. So
this video, we're going to look at how temperature and pH affect.
Okay, so I have a video for you to watch. So please pay attention to the video because after this I will ask you some few questions, okay?
This video, we're going to look at how temperature and pH affect the functioning of enzymes, and therefore the rate of enzyme controlled reactions. Let's start with temperature. This graph here shows how the rate of an enzyme controlled reaction changes with temperature. As you can see, for the first part of the curve, as the temperature increases, so does the rate of reaction. And this is because all of the particles will have more kinetic energy, and so they're more likely to collide and have enough energy to react. After about 37 degrees though, the rate starts to drop rapidly. This is because the high temperatures start to break some of the bonds holding the enzymes together, and so the active side starts to change shape. If it changes shape enough, then the enzyme won't be able to bind to the substrate and catalyze the reaction anymore. And at that point, we say that the enzyme has been denatured. So in this case, the enzyme will become denatured at around 45 degrees. and at that point the damage is permanent. So even if you lower the temperature back down, the enzyme won't start working again. Another important term to know is the optimum temperature, which is this temperature here at which the rate of reaction is highest. So in this case, that would be 37 degrees. All enzymes have an optimal temperature, but different enzymes will have different optimal temperatures. The other factor that can affect enzymes is pH. pH is a measure of acidity, and as you can see on this graph here, if the pH gets too high or too low, then it will lower the rate of reaction. Just like with high temperatures, this is because some of the bonds holding the enzyme together start to break, and so the active site starts to change shape. At first, it just changes a bit, so the substrate can still fit, but less well than normal. This slows down the rate of reaction, but doesn't completely stop it. Soon though, the active site changes shape so much that the substrate can't fit at all, and at this point, we'd say that the enzyme has been denatured. The pH at which the enzyme works best is called its optimal pH, and it depends on where the enzyme normally works. For example, most enzymes in our body work best at neutral pHs of around 7, like in this graph. But the ones that work in the stomach, for example, have an optimal pH of around 2, because they need to be able to function in the stomach's acidic environment.
Okay, so from this video, can anyone want to share the opinion about what is this video is talking about? Okay, Anissa?
So I want to try to explain what the video is all about. So the video is all about the situation where is temperature and pH can affect the enzyme, and the first time at the temperature, if temperature is too high, it will change the shape of the active site of the enzyme, so the substrate cannot bind well with the active site on the enzyme. And if the temperature is too low, the enzyme is not active. But if the temperature is optimal, enzyme can work really well. And if it happens also in pH, like pH, if it's on the optimum one, like with 7 pH, the enzyme can work well. But if it's too high, the enzyme can change the shape, so it can blend well with the substrate.
Okay, correct. Okay, thank you, Anissa. Okay, yeah, so maybe others still confusing about this video. I will explain it to you step by step. Okay, per factor. Okay, so yeah, so benar ya yang Anissa bilang. So this video is talking about the factors that will affect how the enzyme work in our bodies, and there's like some kind of factors like temperature, pH, substrate concentration, and others. Okay, I will explain it per factors. Okay, so the first one is there's an enzyme and temperature. So this is actually what happened to the enzymes when the temperature is increased slowly. And also the rate reaction is also increasing, okay, because the particle move faster and more collision happens. Okay, my question is how like this is the reaction rate is increasing, and my question is about the video. What happened to the enzyme when the temperature it become too high? Okay, Nurul, mungkin?
Answer this.
Yes.
I think the enzyme will get denatured.
Okay, we'll get denatured. Okay, let's talk about something in the molecular level. What kind of things that denature it is? Yes, that's it.
Of enzyme is changed, as I said.
Oh, change. Yeah. Okay, good job, Anissa. So let me get the visual to you. This is the normal enzyme, I would say. Yeah, and this is at the optimum temperature. Everyone can see the whiteboard?
Yes.
Okay, thank you. Okay, so this is the substrate. So when the temperature becomes too high, so it can lead to the denaturation. This is the enzyme denaturation looks like. Yeah, you can see that the active site is changed its shape. Okay, it like looks so abstract. Okay. So if the enzyme is already become denatured, then the substrates will no longer fit, right?
Yes.
Yes, okay, so it loses its function if the temperature becomes too high. Do you understand?
Yes.
Okay, next is the enzymes and pH. So I would say that the different enzyme had a different pH level. So if you pay attention to the video, from the video, why do you think pH could affect the enzyme shape?
I want to try to answer it. based on the videos, like enzymes have a different pH to work optimum. There are enzymes that on the stomach, it's on the too low pH, too low, right?
Yeah.
And but that's fine.
To
Too low.
to into
Asam.
away from the optimum range.
Yes.
Yes.
And there was an enzyme can optimum in 7 pH, I think.
Okay, so you say that if the pH is too far from the enzyme's optimum range, it can also lead to the denature, right?
Yes.
Yes. Okay, so for example, like in the acidic environment, I would say like the acid in our stomach, you already learned about the human digestive system, isn't it, with me?
Yes.
Yes. Okay, so why do you think pH could work best in a very low pH, like in our stomach? Why do you think could happen at the very low pH? Okay, Cynthia.
Because the structure is adapted to acidic environment, so it's stable and active at low pH.
Okay, it's stable at low pH. Okay, so my next question is, why do you think happen when the pH is suddenly become neutral?
The structure will change.
The structure will change, yeah, because each enzyme has an optimum range for there to work best, okay? Like for the pepsin, it's sweet for the low pH, okay? So when this pH suddenly become neutral, then it will lose its function, right? Okay, so next we have an enzymes and substrate concentration. Okay, so at the beginning, when we increase the substrate, the right direction is also increasing, okay? But then at some point, why does the right direction of the substrate is stop increasing even if we keep adding more substrate? Why do you think only at the beginning?
Because all the active sites of the enzyme are already occupied.
Yeah, good job, because all enzymes are already occupied and reach the optimum concentration, okay? So if you're forced to keep adding more substrate, then the enzyme will stress because there is not enzyme to process them, right?
Yes.
Yes, okay. So do you understand enough so far?
Yes.
Okay, good job. So, okay, this is like the summarize. So we already talked about the enzyme activity is affected by the temperature, pH, substrate concentration, and also there's another one like an inhibitors, but we're not going to talk about it today because it goes something more deeply to discuss about. Okay, so each factor can either increase or decrease the rate of reaction, and some can even stop it completely by changing the enzyme shape. Okay. Do you agree with me?
Yes.
Okay, so I think that you already understand enough about this lesson. So today, next is the group discussion, okay? Now I will divide it to you into 3 groups. I already prepared the worksheet. Okay. This is group 1 maybe, and this is group 2. Yeah. This is group 3. Okay, so each group has already got a worksheet. I will explain the instruction. Please pay attention to me for a while.
Yes.
Student. Okay, so for the instruction, you have to read the cast carefully and discuss the guiding question with your group members. Okay, and you have to prepare to explain your answer in front of the class. Okay. And when one group present, another group will be assigned to give like some kind of like summary of the key concept from the class that the group is present. Okay, do you ready?
Ready.
Okay, waktunya mungkin 5 menit or less. warning, okay?
Yes, miss.
Please silence your phone, okay?
Yes, miss. I'm sorry.
Subject the rules means
Yeah. You already doing the job?
Yes, already.
punishment means
Miss, hello, miss.
Give you one warning, okay?
yes.
You understand? Why did you listen to your hand?
Okay, already done.
Already done. Okay, good job. Yes. Okay, so is everyone already finished?
Yes.
Okay, so this is the time. The group one can present the word. Okay, just read carefully.
Sesi juga.
Yes?
Langsung question.
Just the case.
Okay. We are from the one. The case is a biology student forget to refrigerate a test cup and test tub containing an enzyme solution used to break down starch. The test tub was left overnight at room temperature, while another identical sample was stored in the fridge. The next day, they test both tubs with the same substrate. Question number one. What do you predict will happen to the enzyme activity in both tubs? Yes. The answer is the 30 Celsius tub shows a faster initial rate than 4 Celsius tub because particles collide more often.
Okay, question number 2. Which sample will show higher reaction rate? Why? The answer, the 30 derajat Celsius tube will be higher. 4 derajat Celsius is below the enzymes. Optimum activity is low, no stop. And question number 3, what would happen if the enzyme solution were accidentally heated to 80 degrees Celsius? The answer, at 80 degrees Celsius most enzyme denature. And last question, how does this case demonstrate the importance of the temperature of enzyme action? The answer, it illustrates that every enzyme has an optimum temperature. Below it, the rate is limited by kinetic energy. Above it, the rate collapses due to denaturation.
Okay, so thank you, group 1. Group 2 and group 3 understand?
Yes.
Okay, which group 2? Okay, can you give like a summary for the group 1 test?
Okay, from the group one, I can summarize that enzyme have an optimum temperature. Above it, they quickly denature and activity collapses.
Okay, good job. Thank you, group 2, and thank you, group 1. You may sit back.
Yes.
Okay, group 2, you can present your work.
Hello everyone, we are from group 2. So the case is a lab assistant accidentally used a pH 9 buffer instead of the usual pH 7 when preparing an enzyme reaction for catalyze an enzyme that works best at natural pH. After 15 minutes, the reaction seems unusually slow.
Okay, question number 1. Why did the reaction slow down in the basic pH 9 environment? The answer is catalysis ionic side chains lose the correct charge pattern at pH 9, so the substrate binding and catalytic steps are slower. Question number 2. What might have happened to the enzyme structure? The tertiary structure is distorted. The active site no longer complements.
Okay, for the question number 3, what is the term of the condition where the enzyme loses itself permanently? So the answer is denaturation. And for the last number, what what would you recommend to fix the situation in future experiments? The answer is maybe we can use the correct buffer for pH 7 and check the buffer with pH paper on letter before each run. The 30 Celsius shows than the 400 Celsius because particles collect more often.
Okay, so everyone understand?
Yes.
Okay, Ruthie, you can summarize?
So for the summarize about the group 2 presentation is pH away from the enzyme optimum, alter change distribution, distort the active site and causes denaturation.
Okay, is it true?
True.
Okay, thank you, Ruthie. You may sit back. Class,
Give me applause.
Ruthie, silakan.
The case is
Everyone pay attention.
experiment to measure enzyme activity. A student adds increasing amounts of substrate to a fixed amount of enzyme solution. At first, the reaction rate increased rapidly, but then it plateaus even though more substrate is added. For the number one question, why does the rate increase at first but then stop increasing? Initially, more substrate, more ES complex per second, so rate rise. Eventually, every active site is busy, so adding extra substrate make no difference.
So for the second number, what does it means when an enzyme becomes saturated? So the answer is enzyme saturation, all active sites are occupied and an instant. For the third question, could adding more enzymes solve the problem? Why or why not? So based on our discussion, the answer is yes. Adding more enzyme increase the number of active sites, shifting the plateau upward until the new enzymes are saturated. For the last question is how does this case help us understand the relationship between enzyme and substrate concentration? So the answer is it shows the typical Michaelis-Menten curve, a linear rise followed by a plateau, emphasizing that substrate concentration is only rate limiting when enzymes are not saturated. Catalyst ionic side chains lose the correct change pattern at pH 9, so substrate binding and catalytic state are slower.
Okay, so everyone understand?
Yes.
Okay, group 1, can you summarize?
Okay. I will summarize for group 3. Summarize is reaction rate rise with substrate until all active sites are full. Then the enzyme is saturated and the rate plateaus.
Okay, do you agree?
Yes.
Okay, so thank you. You can sit back. Okay, yeah, super work everyone. So I think that you already understand enough about this lesson. Maybe I will stitch those ideas together. Okay, so the first one is there is a temperature. Okay, so higher kinetic energy can speed up collision to the enzyme's optimum range. Yeah, and it can like the temperature if that beyond that heat it will break the bones of an enzyme, so it can lead to the denature, right?
Yes.
Yes. Okay, and the second is the pH. Okay, so each enzyme has an optimum pH level, right?
Yes.
Yeah, if it's too acidic or too alkaline, maybe it will disrupt an ionic interaction between them, so it causing the active site to change its shape. Okay, so it loses in function. Okay.
Yes.
Okay, yeah, so for the last is the substrate concentration from your work. Rate rises linearly until enzymes are saturated. You can see, so it's just linear at the beginning, okay? So you can continue to increasing the rate of reaction if you're adding more enzyme, or you have to stop the product inhibition, where we will to discuss on the next meeting, okay? So, yep, I think that's all from me, because you already understand enough about this today's lesson. So I will give you quiz time, obviously. Okay. So are you ready?
Yes.
Okay. Please, I will send link on the group. Please do it on your own, yeah. Please don't look at others. Okay, we can start now. Okay, everyone finished?
Yes.
Okay, good job. Yeah. So I already looked into your answer, and I think that you guys is already quite understand enough about the environment inside or outside the body that could affect how the molecule work in our bodies. Okay, and what kind of an optimal range to the specific enzymes reaction. So last thing I want. Okay, there's enough. Okay, last thing, I want one person to summarize today's lesson. Did anyone want to help me?
Okay.
Maybe Sabrina?
Sabrina, yes.
Yeah. Boleh Sabrina?
Okay, so today we learned that we have learned about each enzyme has an optimal pH and temperature, and which it works most effectively. If conditioning away from this optimum, the enzyme activity decreases. The concentration of enzyme and substrates also affect the speed of the reaction, but after a certain point, the reaction cannot go any faster.
Okay, everyone agree?
Yes.
Anyone want to give some kind of addition to the conclusion? Or enough? Enough? Okay, good job. Yeah, so always remember that enzymes are very specific and sensitive. Even like small changes in the environment could affect how these enzymes work. Okay, so fantastic discussion for today, I would say. Let's give applause to it. Okay, yeah, I think that's all from me because we opened the class with prayer. I think I must close the class with prayer too. Okay.